Good morning everybody, Chris AMS, hope you're well. Welcome to another video. Today we have a 20 plate Transit Custom 2 litre Eco Blue in for a charging issue. The van apparently wouldn't start. Once they jump started it, it had a battery warning light on the dashboard. So we're going to investigate and see as to why the battery light's on and it's not charging. Stick with us. As usual, it's really great if you can leave us a like and subscribe for our videos. It really appreciate it and it really helps our channel. Getting back to the vehicle, so we're sat in it. We're going to see, obviously, if we can recreate the problem. So we're going to start the vehicle up. And the vehicle does start. It sounds all right when it's running. So let's have a look at the dashboard and see if we can see any issues in that regard. So the engine's running, and on our dashboard we've got a couple of warnings. We have electrical power saver active, charging system service now, and down in the bottom left there you can see the battery warning light is on. So we've got some faults. We've confirmed that the vehicle's seeing a fault. We'll do a code scan on the vehicle now and see if see what the management system is saying. So we've got the snap-on Zeus out. We are plugged in and we've carried out a full system code scan of the vehicle. There's 14 systems that are scannable on this vehicle, and we've got voltage fault codes, generator mechanical performance in the engine management system, and lots and lots of faults in various systems on the vehicle, all are quite likely to be to do with low battery voltage. So let's go into what we're going to do. Is we're going to go into engine management. We're going to have the vehicle running and we're going to see what the management system is seeing as battery voltage on this vehicle. So in our live data, we can see that the engine management system is trying to command the alternator to generate 15.2 volts that we got there. Now if we actually look at see what's actually being produced, we can see that voltage there that is listed by the diagnostic connector. We've only got 9 volts listed, so we've obviously got a charging, or it's not charging or producing voltage. So let's do some tests on the actual alternator and figure out what's going on. Our alternator is located down there on the front of the engine. As you can see, we've had to discombobulate a couple of bits in order to gain a bit of access, and took the airbox out just to see if we can give us a bit more room to play. Now, as you can see down there, we can get to it and we can carry out a test from there. So what do we actually need to test on one of these in order to prove A, it's an alternator problem, or B, it's a wiring problem? So let's have a look. So our alternator is a single wire LIN bus controlled alternator, and it's controlled directly from the engine management ECU here. So it is controlled by a network, a master slave network, which we class as LIN bus. Let's go with that. Which means we need to break out our oscilloscope in order to test it correctly. There's no point just plugging in a voltmeter to the back of the alternator and saying, yep, that's all right, or no, that's not all right. You need to actually check the network signal at this red and blue wire in order to prove definitively whether we've got a good signal or not. So we're going to break out the oscilloscope. We are going to plug in one channel onto our actual voltage, the big battery lead coming off the back there, and the other one onto our LIN signal, and see what our LIN signal is reading. So our LIN bus on the vehicle is a single wire network signal. Unlike CAN, let's say it only runs on one wire, and it uses a 12 volt sweep as opposed to using a 5 volt combined like the CAN network does. So let's just set a scope up quickly. So we want both of these on 20 volts. So I've plugged in our yellow channel into the battery positive, get rid of the trigger, battery positive, and our green channel is going into our LIN bus signal. So let's turn on the ignition. So with just the ignition on, we should get a LIN signal. So at the moment the battery is showing 11.9 volts. Let me just go and turn the ignition on. Make sure that's plugged in. That's no good, is it? Okay, so there we've got our LIN, we're showing a LIN signal. Let's zoom out a bit. Okay, and then that's basically our LIN bus signal sweeping between battery voltage and just shy of 0 volts. What we got going on there? 0.9 volt and 11.9 volts. So that's our LIN signal. So let's start the vehicle and then see what it's like with it running. So as we can see, we've got a good LIN bus signal and we've got low battery voltage. Our battery voltage is now about 8 volts, so I can't imagine this is going to stay running much longer. But we can see via the green trace there that we've got good control of the circuit from the engine management ECU. So it's not, if we found that this was shorted to positive or shorted to ground, then we'd have a concern about the wiring and the control. And you can't check these systems effectively unless you use an oscilloscope to do the job. Just a voltmeter or anything like that is not going to do the job correctly. So an oscilloscope, if you're not using an oscilloscope to carry out this test, then you are guessing that the alternator is the failure point, which can be quite expensive if you put it on and find out you've got a wiring issue. So we've had a look and we've checked the electronic side, and we can see, one, that the alternator is not charging, and two, that it's got good control from the engine management system in order to control the LIN bus circuit. We're going to have a look to see if there's any mechanical issue with the alternator, at which point we may suggest it needs an alternator. So obviously if you're going to do anything, electrical tests are good, but have a quick visual inspection just to make sure that the belt's okay, the pulleys and stuff are okay. So let's have a look at this running and see if we can see any issues. Right, so we can see from that little bit that looks like we've got a mechanical issue with this alternator, probably with the clutch pulley. So we're going to remove the clutch pulley and we're going to have a look and see what's going on and make sure we don't need an alternator as well. Electronically the alternator is fine, but let's check it mechanically and make sure it's just a clutch pulley. Right, so we're going to get the auxiliary belt off and then we can gain access to the pulley. We'll give it a bit of a turn and see what it's doing, and then if necessary we're going to pull the pulley off. Right, auxiliary belt's off. Let's get you in there so you can see what's going on. If I just run my finger along it, you can see that middle bit's supposed to turn, but it will turn independently of the centre. So the outer can turn independently of the centre bit, and the centre bit's the bit that's attached to the alternator. Now this is what they call a clutched overrun pulley, and it's designed to be able to spin independently from there, but not to that extent. So yeah, we need a new alternator pulley. So let's rip it off the vehicle and have a look at it. So we need to take the alternator pulley off this vehicle, and we need a special tool in order to do that. So our special tool is our clutched alternator pulley removal tool. So you can replace the clutch pulley independently of the alternator, which saves a lot of cost. So let's get into removing that pulley. So we need to turn the centre of the pulley, or unwind the pulley off the spline. So we've got two tools that we've got out. We've got that goes on the end of the shaft in the alternator, and this hexagonal bit that goes on the pulley. So these are done up to about 90 to 100 newton meters. So we'll use the big crack bar and a spanner, and we'll crack that off. I got some money. So you can see in there all the rust and crap build up around there to show where it started to separate. So yeah, it looks like the shaft itself is all okay, and it's actually, you can see the blades and stuff spinning, so it hasn't snapped a alternator shaft. So we're going to just replace this pulley, and then we're going to test it and make sure everything's okay. So what we can see, looking at our alternator pulley, I've got the middle jammed up, so this is a clutch pulley, and you can turn the alternator in both directions, meaning that the pulley is spinning with the belt, but the middle bit that actually attaches to the alternator doesn't turn. Now these are designed to turn one way or not the other. Like I say, they're an overrun pulley, so it's designed to be able to spin the belt independently of the alternator if there's an excessive load on the electrical system. But yeah, that is knackered. So let's put a new pulley on it and then check the charging system and see what's occurring. Here's our new pulley. As you can see there, it screws up, yeah, screw on type. Our old one, so let's just go for it. So if we put that in there, we can turn that pulley either way and it moves freely. This is our new one. Again, it's an overrun pulley. So you put that in, you can't turn it forward, but you can turn it the other way. Yeah? So it should lock in one direction and be free in the other, which this one is. In a lot of cases, you find that these seize up solid, so it doesn't turn at all. It's solid, and then you get the belt flap around and then potentially cause the belt to snap. So let's get this on the vehicle, and then we'll carry out our tests and make sure it's all charging okay. So our torque wrench, we need a torque wrench in order to do this up properly. They're at 80 degrees on these transits. We use our technical data system to look that up, make sure we're getting that right. Let's get our spanner on there. Oh shit, drop that. Put that on there. Position. Do you ever have one of them days? Oh. please. Right, so that's all torqued up. We can put the belt back on and we can check the system. So we're back up. Engine's running. See how funny new pulley spinning away happily there. Let's go over to our scan tool. Make sure that's connected nice. So what you'll be able to see, I'm going to do, let me do a save of that screen, and I'll put it up there. Our voltage is now at just shy of 15 volts, which is actually ties up with what the engine management system's desired charge voltage was, if you remember from earlier. And we've got good limb bus as well. So I'm happy that this is rectified. We're going to clear the fault codes on it, give it a test drive, and then return it to the customer. So yeah. Right, so another fault rectified. Again, let's say we carried out tests just to prove that the alternator, we don't want to put a pulley on a faulty alternator, so we wanted to check that the signals in and out of the alternator were correct. As you see, that was all right, and the customer was happy enough just to need a pulley. So lucky for them, they saved themselves a few quid, and someone hasn't just replaced an alternator willy-nilly. I hope you liked our video. Please like and subscribe. Click on the boxes, check out some of our other videos, and we'll see you in the next one. Remember, test, don't guess. Hey everybody, Chris AMS. Welcome to another video. Behind us we've got a 2020 Transit 2-litre Eco Blue. It's been recovered in because it's not charging. The recovery people have been out to it and told them it needs an alternator, but we're going to check it out first to make sure it does. Follow along and let's see if we can get to the bottom of why this isn't working.